A warm good morning to my dear students. So today we are going to see another important concept in thermodynamics. So before going into the concept, the picture shown in this slide represents a hydroelectric power plant. You all know that hydroelectric power plant is used for generating power by using the energy available in water. By using the energy available in water and converting that potential energy into electrical energy. So this is the principle of hydroelectric power plant. Now, the the amount of energy that can be produced using an hydroelectric power plant, that is the amount of work obtained from the hydroelectric power plant, and amount of energy input that needs to be given to the hydroelectric power plant uh, depends upon the various governing factors. So, what are the various governing factors? That is the potential energy available in water, the velocity with which the water is entering the turbine, all that matters. So, all these can be optimized if you have a mathematical equation. So, any problem, if it is converted into a mathematical form, then it is easy to obtain a solution. So, this power generated using an hydroelectric power plant can also be converted into a mathematical equation with the various process variables, that is the velocity of water, height of water, or can be considered as various process variables. So, an equation relating the response, that is the power generated that can be generated in an hydroelectric power plant with that of the various process variables forms a governing equation for the hydroelectric power plant. So we are going to see one such governing equation now. So that equation is called as steady flow energy equation. You all know that energy can neither be created nor be destroyed. It can be transformed from only one form to another form. So this principle that energy can be neither created nor destroyed is can be applied for developing this steady flow energy equation. So here usually the energy is converted from one form to another. So the potential energy available in water is now here converted into mechanical energy, and then it is further converted into electrical energy in the turbine. So now we are going to see that. So in this case, the steady flow energy equation can be used to determine the amount of energy that can be generated by the hydroelectric power plant and to optimize the design of the turbine and penstock that transports the water. Now, this is the governing equation of the hydroelectric power plant, where condition number one represents the uh, entry conditions of water into the hydroelectric power plant, and the condition number two represents the exit of water from the hydroelectric power plant. So in this equation, you can see that U1 plus P1 V1 plus V1 square by 2 plus G into Z1 plus energy input from 1 to 2 is equal to U2 plus P2 V2 plus V2 square by 2 plus G into Z2 plus W from 1 to 2. So here U represents the internal energy and PV represents the flow work and V represents the velocity of water and Z represents the height of water in the hydroelectric power plant. Then Q1 to 2 is the amount of heat that is given as input and W is the amount of work that is given as output. Now this U plus PV put together is called as enthalpy. So the equation gets modified as H1 plus V1 square by 2 plus G into Z1 plus Q1 to 2 is equal to H2 plus V2 square by 2 plus G into Z2 plus W1 to 2. So here W is the power or the work that is obtained from the hydraulic turbine. So if you fix this W as the required parameter, all the other parameters are the input parameters. From this we can find the amount of work that is generated by the hydroelectric power plant. So by using the steady flow energy equation, the pressure, velocity and height of the water can be optimized to maximize the mechanical energy output and thereby the electricity generated. So this can result in significant renewable energy generation and contribute to the reducing the greenhouse gas emission. Thank you.